Okay, so past paper example. Paper 1, this is question 23. So it's an expression that can be written in that form. Wave function stands out a mile off. And then we've got wee part B. So wave function used to be worth 4. Quite often it's worth 3 now. It really just depends. But it's kind of been 3 as of late. But you can clearly see the question always looks like this. X minus alpha. Okay, so again, you would go to your formula sheet. Pick the correct expansion, copy it down carefully. Okay, let's divvy them up. Purple, right, sin x, root 3, okay, cos alpha, cos x, minus k, sin alpha, that's a 1 minus 1. So minus 1 is related to k sin alpha. Nope, I forgot about that wee negative k sin alpha, which you can see there. Okay, rewrite it. 2 negatives make a positive, put the k on top. So 1 is, put the sign on top. Right, k. Two alpha tan alpha that is positive. We're working in degrees. Yep. One over root 3 we know is 30 degrees, so alpha is 30 degrees. Okay, so what do we have? Therefore, equals 2. Our expansion was sin x minus alpha. Okay, and that is our answer. Right, then it says determine the maximum value of that and state the value of which it occurs. Right, so let's relate this to what we started with. Now, we have here 4 plus 5 cos x minus 5 root 3 sin x. Okay, now what did part A ask us? Part A actually asked us root 3 sin x minus cos x. So what is the difference? Well, first of all, you can see that it's got a plus 4. Okay. We also have got a 5, but actually you can see that the negatives are different. So that one's negative cos x, that's positive cos x. So what we've done is we've actually times by negative 5 and we've added 4. So what we need to do is we need to take our 2 sin x minus 30 changes to times by negative 5 minus 10 sin x minus 30, and we need to add 4, and this is what we're now working with. Okay, so it's not a straightforward, oh, it's the same as what you did in part A. Actually, they've times it by negative 5 and they've added 4. Okay, so we need to figure out the maximum value of that graph and where it occurs. Right, so let's think about it. Now, what do we know about a sine graph? We know a sine graph looks like this. What we actually have here is a negative sine graph, and it's been moved up 4 places. So, I mean, you can think of it in kind of steps if you want. you can think about what your points are. So where's our maximum? Right, our maximum is here. What do we know about that? We know it is 91. Okay. So what's happened to this 1? Well, we've times it by negative 10 and we're moving up 4. This minimum here is at 270 negative 1. So first of all, let's times it by negative 10. Again, we can just do sketches. I'm going to make it a wee bit smaller than that. Okay, if we times by negative 10, it's going to be upside down. Okay, so our maximum is now here. So it's at 270, 10. We need to move it up 4, which is going to take us to 14. Okay, so it's something 14. How do we figure out what that something is? Well, we have this minus 30. So we know that normal sine is at 270, but our graph is moved that way 30 places. So that's going to take us to 300. So you can write it as a point like I have. We could write it as max value is 14 occurs when x is 300 degrees. It's another way of writing it. Now, getting the 14, I think, is relatively straightforward to figure out. Using your graph and really thinking things through is helpful. Okay, so visualise it. I think it's the best option for you by doing some wee sketches, whatever suits you in this case.